When it comes to installing a heat pump in a new build premises, the considerations for the heat pump can be thought of right from the outset of the design phase of the project. So this takes into account the type of heating system that's going to be utilised in that property, making sure that there's adequate space externally for the heat pump equipment, and also adequate plant room space for the buffer vessels and domestic hot water generation equipment that needs to service that building. When it comes to retrofit installations, a lot more detail needs to go in the planning of changing, especially when we're changing from fossil fuel technologies to heat pump technologies. So you really need to get under the skin of the existing heating system that is there to understand how a heat pump system can be retrofitted to meet the comfort levels of that building. And that includes understanding what the fabric of the building is, the age of the property, understanding what the heat losses are of that property, and then subsequently how we integrate the heat pump solution into the existing heating system. Before any heat pump is specified for a property, it's essential that a full heat loss assessment is carried out for the property. So there's lots to consider when it comes to installing a heat pump heating system into your property, and it can seem quite daunting to the property owner about how to take that leap from their traditional fossil fuel heating system to a more cost-effective, energy-efficient heat pump installation. But here at Baxi, we're here to help you through that journey with our back office technical support team that are there to help design, develop the right solution for your property. So when we get to the point where the design is fixed and the solution has been identified, and we move into the delivery phase of the project and the installation, we're there to hold your hand through that installation process with your installer to ensure that the installation meets the design. We're there to fend any technical questions on the installation or the equipment itself, all the way through to the commissioning and handover to the property owner. But with many retrofit installations, it's general practice that these take place in the summer months. This obviously reduces any impact and disruption to the operation of the building and maintaining comfort levels. So generally, in the summer months, the heating system is installed and commissioned. Even though that heating system is commissioned in the summer months to the design criteria that we have, when it comes to the winter months, is the perfect time to ensure that any optimization is taking place. This is where we can see how the system is actually operating versus its design. Can any optimization be carried out? In other words, can the flow temperatures be further reduced to maximise heat or improve heat pump efficiencies, as well as weather compensating curves? Have they been set a little bit too aggressive in the first set? Can they be softened slightly to, again, reduce flow temperatures while still maintaining comfort levels in that building? The temperature set point is essentially the target temperature which we're trying to achieve within the building to maintain comfort levels. For argument's sake, 21 degrees. To achieve that comfort level under design conditions, for argument's sake, say -3 degrees outside, we may have a system designed to deliver 50 degrees flow temperature to the heat emitters. As the temperature increases outside, we then can start to reduce the flow temperatures whilst maintaining comfort levels within the building. So as the temperature increases, we reduce the flow temperature. This will increase the coefficient of performance of the heat pump, or the COP of the heat pump. So selecting the right location for the heat pump is a critical part of the planning phase for a heat pump installation. Heat pumps generally work by drawing lots of air through the unit and expelling cold air out into the atmosphere. So it's essential that there's enough free space around the unit to achieve this, and sticking or following manufacturers' guidelines on minimum clearances, etc., is key. We also want to ensure that there's safe access to the unit for service and maintenance requirements, and we also want to ensure that the heat pump is in close proximity to the building it's serving, and the plant room of which where all the heat pump and associated equipment is, so we can minimise any energy losses from that distribution pipework. Lastly, of course, noise has to be taken into consideration, and of course location of the heat pump in proximity to windows, doors, etc. Is a key part of that.